those parts either. The blood exchange only happens at the alveoli. And so those parts to keep in mind when you think about inhaling and exhaling. What's the volume change really coming from? It's coming from the bronchioles and alveoli. So what has the greatest volume? Of all these structures, which one has the greatest total volume?
The alveoli stretches.
It's the alveoli. And it's not, if you just look at this picture, you'd be like, no way, the trachea has just a huge tube that must have the most volume, because you have to think about, there are many alveoli. This is just one branch. There's a whole bunch of alveoli. All of these will dead end to alveoli. Turns out the majority of the volume of your lungs is all alveoli. So really the volume change is happening in the majority of your tissue, and it happens to be just all alveoli. Alright. And so this is the basic kind of game you play with ventilation, is you just change the volume and it creates changes in pressure, right? So when you breathe in, you use muscles to kind of expand your rib cage, expanding your thoracic cavity here. So what's happening to the volume of your thoracic cavity when you inhale? It increases. What do you think happens to the pressure of the thoracic cavity? Due to Boyle's law, it decreases. So here we're going to have a low thoracic, we have a low pressure in our thoracic cavity. That's relatively lower than the pressure in the environment. And so where do you think air is going to go? Into the environment or out of the environment? It's going to leave the environment and go into your lungs, right? And that's how we get air into our lungs. We expand our thoracic cavity, and that creates a low pressure in our lungs, and that drives air from the environment into our lungs. That's how ventilation works. And then when we want to do the opposite, we relax. What happens is, we then decrease our volume. That would mean we have a relatively higher thoracic cavity pressure, and that drives air out back into the environment. So this is all going off pressure gradients. We're just creating pressure gradients by changing the volume of our thoracic cavity. And if you take a cross section of the thoracic cavity, it looks something like this. So here we have our ribs, and then we have these intrapleural kind of sacs. And then here we have our lungs. And so what happens is, as the ribs expand, as your muscles contract, they kind of open up the rib cage. Especially happens when you take a deep breath in. They open up the rib cage, and then what they do is they pull on these intrapleural sacs, and when they get pulled on, they pull on your lungs. You don't need to know the reasons why they pull. You just need to know that's kind of the cascade. One pulls on the other pulls on the other. It's not like your ribs or your muscles are directly attached to your lungs. It's through this kind of suction force that they all kind of pull together when you inhale. And then when you relax, that's the same reason they kind of compress. We good so far? All right. So how does the pressures vary as you inhale and exhale? So this is what inspiration looks like. Inspiration is basically when you inhale. So we're going to start with this middle graph. So as you inhale, as you kind of open up your rib cage, breathe in like this, what's going to happen is you're creating lower pressure. This is right. This is
More
right.
pressure because you're expanding.
And so the trick here is to realize that, sorry, let me write this out in pen, that 0 is atmospheric pressure. This is saying the pressure in your, the pressure that if the pressure is inside your lungs get to 0, they are matching the pressure of the air outside your body. And so what's going to happen here, here is as you start inhaling, so you're going to think here's the start of inhaling. So your lungs expanded, and you're going to start drawing air into your lungs. That's what this bottom graph is showing. You're going to draw air into your lungs. But as air goes into your lungs, as you get more air there, what's going to happen to the pressure in those lungs? It's going to increase, right? And so that's what we're seeing here. We're seeing as air goes into it, and you can just think about this. It's the same example as putting liquid in a balloon. If you put air in a balloon, that pressure is going to the pressure of that balloon is going to increase. Same idea. So that intrapleural pressure is also going to increase as air is traveling inside of it, and also the alveoli pressure goes up too. But the pressure of the alveoli actually go up so high, they already started at atmospheric pressure. So they go to a point where they're so high they're above the pressure of the atmosphere. And so actually during inspiration, they push air out. Despite you kind of collecting air in your lungs, there is actually this kind of pressure pushing it out halfway through inspiration. And that kind of makes sense, right? You're not like an infinite vacuum. If pressure was always low, if pressure was always low, you would just always inhale oxygen, right? You would always inhale air. There would be no stop to it. So what stops is enough air goes into your lungs that it kind of forces air to start leaving. And so that's what happens in expiration. Basically what happens is as your muscles relax, there's an elastic recoil to your ribs, to all the cartilage holding everything in place, and then basically the reverse happens. The oxygen leaves your lungs. As you do that, pressures return to what they came from. And then we see the same thing where, pressure will dip to be negative, but then eventually dip back up to meet back at 0. And so what's happening here is within one cycle, pressure at the intrapleural pressure will do something like this, right? But your alveolar pressure will do something like this. So this point, same as this point here, and that's the division between inspiration and exhalation. Does this make sense to everyone? Alright. Cool. So let's move on then. So let's talk about the resistance to flow. So just like in blood, the flow be proportional to the pressure difference over the resistance. So what causes resistance in basically the flow of air? So here we have our full respiratory system here. And here we have up here we have the upper respiratory tract. Here we have the lower respiratory tract. And in blood flow, what normally caused resistance or changes in resistance? Changes in the radius, exactly, right? And so the same thing is going to happen here. Changes to the radius of these tubes are going to change the flow of air, right? And so in the respiratory tract, you can get, mucus buildup. Right, if this was your tube, and then maybe you're having some bad allergies or whatever, and then mucus starts building up, that effectively changes your diameter, right? And so by having a cold or something like that, you kind of realize you can't breathe really well through your nose. It's really hard to breathe through your nose. That's because all this mucus is building up in your upper respiratory tract and reducing the effective radius of those passageways, making them resistance really high. So you just end up, breathing through your mouth. You kind of bypass. There's all this mucus here. You're just going to bypass it and breathe through your mouth. Turns out to be easier that way. Turns out if you breathe through your mouth, you lose a lot more water than if you just, were breathing through your nose. But that's another problem. Then you can get changes in the respiratory tract through what we call bronchoconstriction and bronchodilation. So the trachea and the bronchi can actually change radius. So for instance, for the bronchioles, they dilate, specifically, they constrict when they get a parasympathetic response. When they dilate, they get a sympathetic response. And so the lungs, just like most organs in the body, have some, are going to be affected